Jupyter Notebook is an open-source web application that provides an interactive computing environment for data analysis, machine learning, deep learning research. It allows users to create and share documents, known as notebooks, that contains code, text, images, videos, charts, graphs, etc. Jupyter Notebook supports various programming languages, including Python, making it a versatile tool for a wide range of computational tasks. Additionally, Jupyter Notebook supports rich multimedia content, such as plots, charts, graphs, and interactive widgets, facilitating data visualization and exploration. Its collaborative nature allows users to share their notebooks with colleagues, collaborators, or the broader community, fostering collaboration and knowledge sharing. One other main feature of Jupyter Notebook is it allows users to convert the notebook into other formats, such as HTML and PDF. It also uses online tools and MBV Viewer, which allows you to render a publicly available notebook in the browser directly. Jupyter Notebook is a versatile tool used for interactive computing, data analysis, and documentation. It allows users to create and share documents containing live code, equations, visualizations, and explanatory text, fostering a seamless integration of code and narrative. In the field of AI, Jupyter Notebook plays a critical role due to its usability and flexibility. It provides an ideal environment for prototyping machine learning models, exploring data, and visualizing results in real time. By allowing users to write and execute code in small modular cells, Jupyter Notebook promotes an iterative and exploratory approach to AI development. Its support for multiple programming languages, including Python and R, makes it accessible to a wide range of AI practitioners. Moreover, Jupyter Notebook facilitates reproducible research, enabling researchers and data scientists to share their work transparently and collaborate effectively. Jupyter Notebook importance lies in its ability to streamline AI workflows. It enhances productivity, promotes best practices in code development, and facilitates the communication of ideas and findings. Jupyter Notebook operates on a client-server architecture. When we launch Jupyter Notebook, it starts local web server in the background. The Jupyter Notebook app serves as the client interface, communicating with a computational kernel running on a server. The notebook document, represented as a JSON file, contains live code, text, equations, and visualizations. Each notebook is associated with a specific kernel, responsible for executing the code written in individual cells. Users can iteratively execute code cells within the notebook, with the kernel processing the code and returning the output, including text, plots, and tables. Jupyter Notebook facilitates interactive computing, meaning you can modify and rerun code cells iteratively, allowing for rapid prototyping and experimentation. It supports rich output, enabling interactive visualizations and multimedia elements. Additionally, users can save their notebooks locally or share them with others via platforms like GitHub or Jupyter Hub, making it a versatile tool for collaborative research and data analysis. The Jupyter Notebook dashboard serves as the landing page when you launch Jupyter Notebook, providing an overview of your file system and allowing you to navigate through your files, folders, and notebooks. It mainly comprises three main tabs: Files, Running, and Cluster. The Files tab serves as a file explorer, displaying the files and folders within the current directory. Users can navigate through their file system, create new notebooks or text files, and upload files to the notebook server using the Upload button located within this tab. The Running tab provides a list of currently active notebooks, allowing users to monitor and manage their running sessions. Additionally, for users working with Python, there's a Cluster tab available. This tab is specifically designed for Python users and is linked to the IPython kernel, which is an extension of the standard Python kernel. The Cluster tab is used in conjunction with IPython's parallel computing framework, enabling users to distribute their computations across multiple cores or even across multiple machines for improved performance and scalability. Overall, the dashboard tabs offer convenient access to file management, session monitoring, and parallel computing capabilities within the Jupyter Notebook environment. The Jupyter Notebook user interface provides a versatile and interactive environment for computational work and data analysis. At the top of the interface, a menu bar offers access to various functions such as saving, editing, and running code cells, while a toolbar directly below provides quick access to common actions through icons. The main area of the interface is comprised of individual cells, where users can write and execute code, enter text, or include markdown formatted content. These cells can be in either edit mode for content editing or command mode for performing actions on cells themselves. The notebook also includes a kernel indicator, indicating the status of the notebook's kernel, and an output area below code cells to display results and output generated by executed code. With intuitive navigation options, keyboard shortcuts, and a comprehensive dashboard for file management and session monitoring, the Jupyter Notebook UI streamlines the workflow, fostering efficient and collaborative computational exploration and analysis. Markdown cells in Jupyter Notebook provide a convenient way to format text and documentation alongside code and data. With Markdown, users can easily apply various formatting styles using simple syntax. For instance, users can make text bold by enclosing it in double asterisks or underscores, italic by enclosing it in single asterisks or underscores, and strike through by enclosing it in double tildes. Headings of different levels can be created using hash symbols, while lists, both ordered and unordered, can be generated using asterisks, plus signs, hyphens, or numbers followed by periods. Hyperlinks and images can be inserted using square brackets for the link text and parentheses for the URL or image path. Code blocks can be included by enclosing code within triple backticks, and tables can be constructed using pipe characters to separate columns and hyphens to define column headers. Markdown cells enhance the readability and organization of notebooks, enabling users to create well-structured and visually appealing documentation to accompany their code and analysis. Code cells and execution are integral components of Jupyter Notebook, facilitating the seamless execution of code and interaction with computational tasks within the notebook environment. Code cells serve as containers for writing code snippets, and each cell can contain code written in a specific programming language supported by the notebook's kernel. These cells are executed individually, allowing users to execute code iteratively and independently. Upon execution, the code within a cell is sent to the kernel associated with the notebook for processing. The kernel executes the code and returns any output generated by the code execution, including printed statements, variable values, or graphical plots. Users can execute code cells using various methods such as clicking the Run button in the toolbar, pressing keyboard shortcuts like Shift plus Enter, or selecting Run cells from the Cell menu. For example, executing a Python code, cell containing arithmetic operations would produce output displaying the result of the operation. Kernels in Jupyter Notebook are essential components responsible for executing code written in various programming languages. Each notebook is associated with a specific kernel, dictating the language and execution environment for the code within the notebook. For instance, a Python kernel executes Python code, while an R kernel handles R code. Kernel management involves tasks such as starting, stopping, restarting, and switching between kernels within a notebook. For example, if a code cell encounters an error during execution, users can restart the kernel to clear its state and resolve the issue. Similarly, users can switch between kernels to work with different languages or environments within the same notebook. This flexibility allows for seamless integration of multiple languages and tools within a single notebook, enhancing productivity and enabling diverse computational workflows. Jupyter Lab is an interactive development environment, IDE, provided by Project Jupyter, offering a flexible and extensible interface for working with notebooks, text files, data, and interactive computing tasks. It serves as an evolution of the classic Jupyter Notebook interface, providing a more integrated and feature-rich environment. In Jupyter Lab, users can organize their work using a tabbed layout, allowing for easy navigation between different documents and activities. The interface is highly customizable, with support for arranging panels, creating custom layouts, and adding extensions to enhance the functionality. For example, users can split their workspace into multiple panes, each containing a different document or tool, such as a notebook, terminal, or file browser. Furthermore, Jupyter Lab supports a wide range of file formats and data types, enabling seamless integration with various data analysis and visualization libraries. Overall, Jupyter Lab provides a powerful and user-friendly environment for interactive computing, data analysis, and collaboration, making it a preferred choice for many AI engineers.